Greetings and welcome to the course on curriculum and course design. Week 1, Unit 3 on evolution of engineering education. In the last unit, we understood what curriculum is and should be. In this unit, we will try to understand how engineering education has evolved over the period of time. Now, there are one can identify 5 major shifts in engineering education during the past 100 years. This was explored in great detail by Freud and et al. In 2012 of IEEE proceedings. These five shifts are from hands-on and practical emphasis to engineering science and analytical emphasis, to outcomes-based education and accreditation, to emphasizing engineering design, to applying education, learning and social behavioral science research, to integrating information, computational and communication technology in education. We will explore these 5 shifts, what has happened. First shift happened in late 1940s. It was facilitated by Frederick Terman of Stanford University and Grinder report. What happened until then, engineering education was a little more like apprentice and practice-based education. Whereas Grinder report stressed the need for adequate science and engineering sciences and engineering curricula. This, even today, most of the universities around the world still believe in that. But in the process, what has happened is, after all subjects grow with time, the number of engineering science subjects in engineering programs have increased phenomenally, and practically engineering part got pushed out of the curriculum or drastically got reduced. That was the first shift that happened, and we still more or less operate within this kind of framework. First shift. And then what happened, second shift happened as a consequence of requiring accreditation of an engineering program to ensure quality. Because some agency will have to be out there in every country to ensure that there is some kind of quality is maintained by the institutions offering engineering programs. Towards this, ABET of USA defined the EC 2000, which we have seen in the previous unit. Now it essentially tries to say an engineering graduate needs to participate in wealth generating activities as a responsible citizen. This in today's world requires that he be able to effectively work in a team, communicate well with peers and society at large, continuously learn and understand the impact of technology on society and environment. This is a really major shift which we have not yet fully adopted in India in engineering education. So essentially, EC 2000 will say all engineering graduates are required to attain some well-defined outcomes. So some agency will have to be there to define these outcomes. Most of the countries have defined similar criteria as program outcomes of their engineering undergraduate programs. India defined graduate attributes only in 2013 and relabeled them as program outcomes in 2015. Right now we use the word program outcomes. While because it is required by the National Board of Accreditation in India and our programs have to be accredited, all institutions in India acknowledge the importance of these program outcomes, but many of them are yet to make efforts in adequately incorporating learning experiences to meet these outcomes. We are still far from that, though on paper we demonstrate that we have achieved all these outcomes. What has happened is that emphasis on engineering science and mathematics has gone too far. And as I mentioned earlier, many engineering courses got pushed out of the curriculum. If you now look at the current curricula in India, you'll find not more than 4 or 5 true engineering courses, that too design-oriented courses in engineering programs. Out of some 40 odd courses that we undergo, only 4 or 5 possibly at least nominally address engineering or engineering design. So what has happened is people have realized that design as a major distinctive element of engineering should be enhanced, because that is the purpose of really an engineer. So National Academy of Engineering, there is a particular book that they produced, The Engineer of 2020. These are their statements. Engineering is a profoundly creative process. A most elegant description is that engineering is about design under constraints. If you define engineering broadly as design under constraints, you have to train them to do that kind of job. So here, the engineer designs devices, components, subsystems and systems to create a successful design, in the sense that it leads directly or indirectly to improvement in our quality of life, must work within the constraints provided by technical, economic, business, political, social and ethical issues. See, that is what engineering, if you look at it as design under constraints, the constraints come from technical, economic, business, political, social and ethical issues. So to that extent, an engineer should know also how to operate under these constraints. Unfortunately, our present day engineering programs do not look at any of them at all, other than technical. So that is where we need to grow, that the program, the curricula will have to be seriously reviewed to make sure that all these constraints, the graduates learn or know how to operate under the constraints. Towards this, MIT has produced what is called CDIO Framework. Graduating engineers should be able to conceive, design, implement, operate complex value-added engineering systems in a modern team-based environment. While they have stated this, I do not think many of the American universities also follow strictly CDIO framework for all courses. Maybe the entire program, yes. One of the practices is, while in India we have a 4th-year project in all engineering programs, in whatever way they have been executed, but we do have a compulsory project to be done by graduating students. Whereas in USA, that is not compulsory. Some programs do have a project, and they call it capstone course. Okay, that is a civil engineering term, is a capstone course, but capstone project is not compulsory in American education system. Now, what the CDIO framework or this third shift that has happened led to what is called introducing a course in first year itself on engineering design. Many of the universities now, they do offer a course right in the first year in engineering design. Now, till now what has happened is, even today in many of the institutions in India, we talk about sequential learning. That is, we understand the engineering science or mathematics involved in something and keep on acquiring this knowledge and try to use all this knowledge in the final year to design something. But until then, none of the courses really prepare students for the activity related to design. Now, it has been established, it is quite possible without necessarily understanding all the what do you call underlying engineering science and all that, it is still possible for the student to experience the process of design. And this has been practiced in quite a few institutions across the world, and it is now possible in India also. A few institutions have started incorporating right in the first year a design course. So this design course, what it does is it gives an experience to the student for all the elements involved in any engineering activity. It can be team based. It can be, that is, you without getting into the very basic details. It is still possible to conceive a product, and you may learn it in a haphazard manner, but whatever it is possible, especially with the knowledge available through the internet. It is possible to actually design and actually fabricate a product right in the first year, or at least solve a good engineering problem in the first year. This can be called something like a foundation course. Okay. Now, fourth shift happened in our attempt to use all the knowledge that has been acquired through research in educational psychology, social psychology, cognitive sciences, educational neuroscience. Now people learn lead to an understanding the different domains of learning, including cognitive, affective, and psychomotor domains. We have seen in the earlier courses related to this, like OBEA, that learning can happen in the three domains or even four domains: cognitive, affective, psychomotor, and even spiritual domains. Okay. Now, after all, learning takes place in the brain, and only in recent decades we have started understanding a little bit about social psychology, cognitive sciences, educational neuroscience, and there are some limitations and possibilities that happen in the brain because of the uh, huge number of neurons that exist in the brain, and the kind of structures that they've evolved into can also provide you both the limitations and possibilities in learning. And we can make use of some of those understandings and convert them into some design our own instructional methods. So, it is now possible to systematically design a program or a course to meet educational objectives stated as program outcomes and program specific outcomes or as course outcomes. This is what we will do in this course, namely both for curriculum design as well as course design. We will try to make use of some of this knowledge, and we still do not know all the things that are involved in learning, but to whatever extent that we have understood till now, we'll try to make use of it in designing the courses as well as curricula. And as the time evolves, we start understanding more and more of what do you call how we have been evolving as humans. Possibly this fourth shift will keep on further progressing. Then the fifth shift has come. It is related to integrating information, computational, and communication technology in education. ICC technologies offer many possibilities to address the present day issues of cost, scale, access, and equity in higher education. That is the strength of this. What happens is, in a classroom, if you have 40 to 60 students in a class, each student is different from the other, because the kind of experiences that he has gone through right from his childhood to come all the way to engineering education, they are different. No two students are alike. But then in a class till now, based on the technology that we have, we only can address some fictitious average student and direct our teaching process towards that person. Okay? So some people may find it slow, some people may find it faster, and you try to keep correcting that, maybe paying attention through tutorials, or students themselves may find their own way of interacting with one another to address these different issues in difference of learning. Now, but now the technology is coming and offering a possibility. First of all, you cannot individually, in a face-to-face mode, you cannot individually address each person separately. But today's technology will allow you to address needs of individual students while taking care of cost, scale, and access and equity in higher. It is potentially possible, not that it is still happening, but technologies are there, and many people are attempting to do this in different ways. And the consequence of this is, all of you might have already experienced MOOCs, online courses, academic management systems, learning management, learning analytics are possible using ICT technologies. Potentially, there are many possibilities, but it requires all faculty to put in efforts to achieve at least part of this. Somehow the COVID forced all the faculty to get used to a little bit of online courses, and NPTEL has given experience how to use MOOCs or some kind of learning management systems as well. So fifth shift is also happening in India to a limited extent, but more can be done on this if the faculty take initiative, because you have hundreds and hundreds of courses. Even if two courses have the same title, let us say fluid mechanics, it doesn't mean that fluid mechanics as taught in two different institutions is exactly identical. Okay? So to that extent, if the faculty member wants to make use of his view of that particular subject, he has to put in the effort to make use of these technologies and present it that way. Okay? So these are the five shifts that have happened. Let us look at engineering education in India until recently. Our most bad habit in India is we never articulate our assumptions and goals very clearly on a piece of paper. Because if you express on a piece of paper, then someone can argue about it, but then through that kind of discussion only we clarify our assumptions and goals. You take any of the course manual in any engineering institution, they do not say what the goals and assumptions are. All the time we look at our engineering program as a collection of some courses. Yes, there is some common understanding. Based on that, we struggle through putting a set of courses, but never put a goal towards that. We never articulate the goal of engineering program is to train somebody as an engineer, and defining what engineering is, what engineer does. We do not say any of that. Then what happens? in India, especially multiple stakeholders with different perceptions and interests. We have so many stakeholders, starting from students, faculty, parents, management especially, and then you have state government agencies and central government agencies. All of them have slightly different view of different goals of engineering programs. Like you take a private university or a private engineering college, the most surviving thing is that the seats have to be filled and the pass percentages will have to be high. But seats cannot be filled with very good students. So what we do, we make concessions on what kind of students can enter the program. But then and having entered them, we have to also make sure that they pass out. So what happens? We make all our efforts to compromise these two extreme requirements. And if you look at national level also, we have been drifting far too long without any major reviews. Of course, NEP 2020 has done one of that, but I am yet to see a program that truly integrates all this and presents a major review. Okay, we will try to integrate all this in our approach to curriculum design. Another issue which doesn't happen anywhere else in the world, we created mega universities with hundreds of affiliated engineering institutions. When you have a large number of affiliated non-autonomous engineering institutions, the problem becomes different. The problem now becomes how do you perform or conduct the mega activities, you can say, like admissions, conducting exams, making sure, and we have to follow a large number of practices in the name of transparency, and then evaluating the student performance in a centralized way and declaring the results in a centralized manner. So when you have such a thing, the focus becomes the centralized process rather than teaching and learning. And we haven't come out of that as yet. And in this process, in India, we are quite well known in practically in all fields. Our regulatory mechanisms to start with are poor and further poor at the implementation level. So we have to overcome many of these issues to improve the quality of engineering education. Now, I have experienced in checking with a large number of faculty in various workshops. If you ask them to define what engineering is, many of them falter. So what does it mean? Without having a clear idea about what engineering is, we are teaching our engineering courses. We are conducting our engineering programs. Let us say, I'm not saying this is a unique definition of engineering, but this captures all the issues related to engineering. If you want, you can slightly modify the wording and make it your own definition. But engineering is finding and delivering effective solutions to real life technical problems within the given material, technological, economic, legal, and social and environmental constraints through the available application of through the application of available knowledge from mathematics, science, technology, engineering sciences, and engineering practice. So this tries to capture all of them. If you look at the program outcomes that are given by National Board of Accreditation, they do capture many of these things already. Though NBA itself doesn't give a formal definition of engineering. Okay. So we have a long way to travel in truly understanding what engineering is, engineering programs are, and how do we improve the quality of engineering programs through good curriculum design and course design. And in the next unit, we will try to understand some features of NEP 2020. The reason is, while some states do not completely agree with the NEP 2020 completely, but implicitly many of them are accepting, at least with regard to higher education, the features provided by NEP 2020. It is kind of NEP 2020 is a kind of a set of wish statements. These are all the things that we want to attain. On that, we cannot seriously have objection. But how do you go towards that is the issue. And that is where all your participation and your efforts are required. Thank you very much.